The main deficiency of the internet as we know it today is that everything that goes on in it can be surveilled. But there's a way to operate in the internet by having another infrastructure layer, a hidden layer of communications that is hidden by encryption. Today we're going to talk about ultra-secret solutions to accessing networks while going through a public internet connection. This is admittedly an advanced topic, hard to discuss this without getting very technical. As a starting point, I'll introduce you to two terms, onion routing and the darknet. Onion routing was made famous by TOR. I've talked about TOR in a lot of old videos. If you haven't heard of TOR, don't worry, I'll give you an intro, but we'll go a step further. In this video, I'll introduce you to Lokinet and then compare that to TOR. There are also other concepts here that may be new to many of you, like the darknet versus the dark web versus the internet, and how some of these networks give you this kind of access to these secret networks. Some of these are favored hangouts by criminal elements and hackers. Some are used because access cannot be censored. These secret networks have pluses and minuses. Some have even labeled these as government honeypots, meaning they are actively used for government surveillance, which they are. But believe it or not, it is a certainty that three-letter agencies and their operatives use these secret networks, so even the state sees their value. These ultra-secret networks are ripe with potential, and some apps are beginning to use them in a big way. Let's give you a rundown on this important topic. Stay right there. When it comes to accessing the internet anonymously, the big daddy of all the secret networks is TOR, which originally stood for the Onion Router. TOR was actually originally invented by the US Navy in order to allow secure and hidden communications over the internet. It is now a non-profit foundation run by volunteers. Onion routing, popularized by TOR, is a way of sending data back and forth through the public internet in a way that makes it virtually impossible to detect where the data originated from. The basic concept is that if you're using the TOR network, your content is wrapped in an encryption layer. A message passing through TOR is sent through at least 3 server nodes, selected randomly, each node wrapping the message in another encryption layer. This prevents each participating node from seeing the message and also knowing where it came from, other than the prior node. At the end, the encryption layers are peeled off and the message forwarded to the open public internet via an exit node. But the messages assume the IP address of the exit node. The original IP address is not known. We visually associate these encryption layers to the image of an onion, imagining each layer peeled off. Without going through the technicalities of how this works, this onion routing has gone through the test of time and has proven to be very secure. In fact, comments by Snowden showed that the three-letter agencies were concerned because they couldn't uncover the data that passed through TOR. The government did come up with a way to spot targets on the internet, even with TOR, through a triangulation technique called an end-to-end timing attack. But this was done outside of TOR. It was just used to compare timestamps of internet traffic and trace that back to individuals under active surveillance. The TOR ecosystem today is run by volunteers. Some servers are provided by universities, private individuals, foreign states, and three-letter agencies. Even though some TOR nodes are likely provided by governments for surveillance purposes, the reality is that with the addition of HTTPS in normal traffic, TOR exit nodes in truth cannot see much other than knowing the destination host. TOR is censorship-free as well and is important for allowing open communications for people in oppressed places. It has a very important function. TOR operates with around 6,000 nodes all around the world. In addition to TOR being used to go through the internet anonymously, TOR also allows access to services inside TOR itself, and these are called TOR hidden services, meaning you never even go out to the open internet. Everything occurs in the encrypted environment of TOR where there are no IP addresses. The TOR hidden services, mostly web servers, are popularly known as the dark web. This is the place where people do things like buy hacked data anonymously, buy illicit drugs, get fake IDs, and do all sorts of criminal activity. These dark websites are constantly targeted by the FBI, but this is also the place where those oppressed in some country can talk to each other without fear of being identified and incarcerated. So, in spite of the potential for evil in the dark web, it serves an important purpose to many. I'm sure the dark web is also used by three-letter agency operatives to talk to each other. Now, this is a very important point. Do not make any moves with TOR without watching this entire video, or you will likely be put into a surveillance list by some three-letter agency. The way the typical user will encounter TOR is to search for TOR and then go to the site torproject.org. This is a certain mistake, but just listen before making a move. What you will find on torproject.org is a download for the TOR browser. The TOR browser is basically a reworked Firefox, which is designed to route all the browsing traffic solely through the TOR network. While this makes it super easy to use, since in theory all you have to do is install a browser, this is also the limitation of TOR for the non-techie user. TOR is typically only available as a browser, which means it can be used only for accessing websites. It is not used to access email, do video chats, voice over IP, or other internet services that are not associated with HTTP. There is a way around this, but I'll get to that later. In general, a TOR browser is used to access anything using the TOR network, whether you're using it to hide your identity on the public internet or to access the dark web or hidden services inside the TOR network. While normal internet traffic relies on the usual internet naming convention of domains, TOR hidden services use an address that will only go inside TOR. The limitation of a TOR browser, though, is that it only sends web traffic to websites. In order to send traffic other than web traffic, special procedures are necessary, and that is called TOR routing. So again, to make it clear, this is TOR browser versus TOR routing, two different things. TOR routing means all the traffic is routed through TOR, not just web traffic. Unfortunately, this is not something an average user can do. I created a special product called the Brax router, which allows you to do TOR routing. That is a feature included in the software I made. It is also part of our Bytes VPN service called Bytes TOR, where we provide a gateway to route you to TOR when you need it. This is basically the limitation of the TOR infrastructure. There's no easy way to do this TOR routing automatically since the TOR project does not make such tools. And TOR routing is really just possible through Linux. So you're not able to route directly through TOR using Windows, macOS, or iOS. There is an app on Android that we pre-install on phones we sell, and it is called Orbot. That allows you to use TOR for all traffic on an Android, and it will work on any Android whether de-googled or not. This is in fact TOR routing, but it is limited to Android. Orbot is an official project of torproject.org. Although I offer a solution to use TOR beyond just web traffic, usually you need something else, like additional hardware, to have a TOR routing. The alternative to TOR is Lokinet. Lokinet works very similarly to TOR. It also uses an onion routing protocol, though they claim it to be a more polished version with better performance. And the naming of Lokinet versus TOR, I'm guessing, is a play on the brothers Thor versus Loki in the Marvel comics, though Lokinet has no evil implications in this case. Lokinet, by the way, is the communications infrastructure of the Session Secure Messenger app. So I already mentioned it before in the context of this session video. Anyway, what's different about Lokinet is that when you install their software, it is an onion router by default. It is not just used for web services, so no special hardware is required to route your entire internet connection through Lokinet. The idea of routing your entire traffic instead of just some limited protocol like HTTP is called SOCKS-5 routing, and this is a standard capability of Lokinet. And the other difference with TOR is that you can install Lokinet on Linux, Windows, and Mac OS, so you can onion route on all of these platforms. Currently, the Lokinet apps for iOS and Android are under development, so that is going to come soon. This puts it way ahead of TOR on the usability scale, since there's nothing special for most PC users to do to enable full internet routing or SOCKS-5 routing. Just install Lokinet and turn on the switch to connect to an exit node like I show here, and all your traffic will go through the Lokinet network. There are differences and there are similarities with TOR. As far as similarities go, Lokinet appears to be running at a speed that's comparable to TOR, meaning traffic seems to be capped at around 10 megabits per second on download and something much slower on upload. In today's world, this is slow. It is not a suitable speed for video streaming, for example. Because TOR and Lokinet are offered as a free service, they are not particularly fast. Lokinet is a smaller network compared to TOR. While I said that TOR has around 6,000 nodes, Lokinet displays a node count of somewhere around 1,700 nodes, which is still a fairly sizable number for a smaller network, and certainly has eclipsed other competitors in the ultra-secure network area like I2P and Freenet. I'll add those two solutions in the mix later on, since they also have a specific role. But back to Lokinet. Lokinet is the backbone of the Session Messenger app, so it is actively used beyond just accessing the open internet. What is interesting though is that when you use the Session Secure Messenger app, the traffic occurs inside Lokinet and stays inside Lokinet. It doesn't enter the open internet. This frees it from external surveillance. An end-to-end timing attack using Session isn't going to work. Session forwards the message, which is stored by the Oxen nodes running Lokinet, and the retrieval of messages is not done in real time. So any number of users could be retrieving Session messages from Session servers, and there's no way to know who's downloading those messages externally. Additionally, the Session apps communicate using private keys stored on the client Session app itself, so the Lokinet network is not aware of who's talking to whom. Let's just summarize the relationship between Lokinet and Session again. Both products use Oxen nodes. Oxen nodes are servers created by people to support the infrastructure of Oxen, and these people get paid by Oxen cryptocurrencies. Oxen is a fork of Monero, so it's a private cryptocurrency. The typical user does not need to get involved with the cryptocurrency side. This just ensures that there's an economic justification for running a server. The entire infrastructure of Lokinet and Session, and even onion-routed internet traffic, is supported by these 1,700 nodes. Focusing only on how Session integrates with the onion routing, you can see that Session operates entirely in the darknet. And notice how I used a new term, darknet, instead of dark web. While the TOR browser is used to access the dark web or web servers inside TOR, the darknet includes all possible internet protocols and not just limited to websites. This is where TOR does not have a really good app infrastructure. While some simple messaging apps have been made to operate inside the TOR darknet, the reality is that this really hasn't advanced much. To this day, there are no significant apps focused on using the TOR network anywhere near what the Oxen Foundation is doing with Session. The limitation of Lokinet, though, when accessing the internet, is that Lokinet does not have as many exit nodes as TOR. I think I estimated that TOR has over 1,000 exit nodes, and these exit nodes are what's visible on the internet. I don't know the number of Lokinet exit nodes, but it can't be more than a few hundred. So in theory, Lokinet is more vulnerable if someone is observing internet traffic going in and out of Lokinet with end-to-end timing attacks. However, as I said earlier, this is not really an issue with session, since session does not go to the exit nodes. Most everything transpires within Lokinet. Also, for people wanting to have anonymity but don't have a TOR router, then being able to install Lokinet to do onion routing is definitely a viable alternative. First of all, before you start downloading TOR and Lokinet, you need to make sure you are using a VPN. TOR, and I'm sure also with Lokinet by now, are very likely under government surveillance, meaning expect that someone is logging the IP addresses of everyone downloading TOR in the open. This should create a pool of possible suspects if some three-letter agency is looking for someone using the dark web for some nefarious purpose, like using the old Silk Road. So using a VPN will at least hide your home IP address from this potential surveillance. The question is, why would you even need a VPN after you install TOR or Lokinet? Definitely, having only a TOR browser does not offer sufficient protection. Your traffic on the internet with Zoom for video, WebRTC, email, BitTorrent, DNS, and so on will reveal your IP addresses to all. A TOR browser cannot intercept non-web traffic since you have nothing to capture the SOCKS5 traffic with. There are operating systems designed to do SOCKS5 routing directly under Linux. Examples are Tails OS and Unix. Both are Linux distros. The Brax router software I made is also doing TOR routing under Linux. It works the same way as Tails and Unix, except that I do the routing over hardware, in my case a Raspberry Pi. But assuming you use TOR routing with a supporting Linux OS or using my TOR products, then why use a VPN? We know that a VPN is not as secure as either TOR routing or Lokinet routing. The problem is speed. As I mentioned earlier, TOR has a cap of around 10 megabits per second, which seems to also be the same used by Lokinet. This makes onion routing a specialty kind of situation. If you're needing ultra-secure traffic because you're operating undercover, then of course you cannot just pop into the open internet. However, for the vast majority of us, normal everyday activity is fine using a VPN. A VPN obscures the IP address from the target servers and is sufficient to prevent profiling and such targeting. Onion routing or operating inside the darknet is only needed by a few special situations where extra secrecy is desired. For example, if you happen to be a physics student in college and wants to learn more about nuclear stuff on the internet, to avoid being put into some surveillance list, I would likely think that this should be done through onion routing. So for the occasional need for full onion routing, the more portable solution is Lokinet. And for those running my Bytes VPN service, you can route your traffic through TOR using our Bytes TOR service, which comes free with the VPN subscription. And if you're on Android, you can use Orbot for free as well. So there are several options here. When you're in a dark net, there are no IP addresses. Nothing allows the kind of tracking that is normal with the normal internet. So all your traffic never becomes visible to the internet. It's just a bunch of encrypted traffic that never comes out in the open. This is the bulletproof solution that makes the TOR dark web so popular. There are other well-known players in this darknet space, and these are I2P and Freenet. Of the two, I2P is the larger one, but the fact is that after many years of having installed I2P, there's nothing compelling for me to want to use it. You see, there's no real application. Many people use TOR for onion routing through the internet. I2P does not really do internet exit nodes. The purpose of I2P is to operate as a darknet only. Same with Freenet. Both implement different ways of obscuring traffic and is not really the same kind of onion routing as TOR. And the reason it can operate differently is because it is a darknet only solution. You could make servers that talk to each other inside I2P only, or servers that talk only inside Freenet. But no one really built an application as sophisticated as Session to work inside I2P. I2P is popular for those doing Bittorrent. Doing Bittorrent inside a darknet obviously makes it impossible for the user to be targeted. So that's the main use of I2P today. One of the issues I wish we could easily solve is how to access our home servers from the outside internet. For example, let's say you're running a Nextcloud server at your home. Currently, you'd have to open your home network using port forwarding and basically allow potential hackers an entry point into your network. In the future, if devices had a direct way to route through the darknet only, you could access your home devices through the darknet safely as if it were a local LAN. A lot of applications are possible here and could simplify traffic. All you need to know is the host name for Lokinet, for example, which is some node ID with a .loki domain extension. These host names are not public, so they're pretty hard to scan, like in this example. It could, in theory, remove the need to run things in the cloud. It could go straight to your home server. But for this to work well, all devices need to have darknet access on all platforms. Lokinet does not have this yet. Their mobile solutions are in the works. And there's also the speed problem. But when that is released, we could at least start thinking about solutions like this. Folks, I created 3 products that serve the purpose of reducing your metadata footprint in this surveillance-heavy world. First, we have the Brax2 phone, which has no Google ID and is thus invisible to Google. We also have Bytes VPN, which is important for hiding your IP address, encrypting your content, protect your DNS traffic, and give you a Tor gateway. Finally, we have a Braxmail product, which is an email service that removes the metadata from the header. There's never an IP address or anything that will show where the message is coming from. These products are on my app BraxMe. The link is in the description. Thanks for watching and see you later.